check. For concurrent view. I'm and what is up with my everyone? Not ideal. Fine on OBS. Very convenient. Drop 0 frame. Oh, hello. So I pulled up the review, but I also pulled up the winter break assignment, and I have other practicey sort of things like do sub worksheet. So I am very flexible in terms of what I talk about today, hopefully. I also have dinner. Lazy to shut the mic off. Feel free to shoot questions if you have any. What's on the menu? Mac and cheese with black beans, spinach, green chilies, and meatball. Nights, delicacy. My stream is mad lagging. Looking at this live stream, fine. Chat might be a little laggy. Might not. Might be a little ahead of you. Oh well. No questions so far. Everything's. I've graded 2 of the 3 classes for the free response retake, and went all right. Yeah. Not that many 10 out of 10s, but I think so far, no 0 out of 10s, maybe 1. That's pretty good. Maybe the reasoning behind chapter 4, question 2. Okay. Oh, yeah. Right. So that should have an equal there. For what it equals to. I think we had this before. I think this is one of the ones that repeats from when we've had this like review for what, last test? 2 tests ago, probably. But the whole idea is that what we're looking for is oh no, this is brand new for this test. No, maybe last. I don't know. Anyways, if f is continuous on the interval, then there's somewhere where the integral equals, and so what the integral equals is definitely not the difference quotient. So this is trash. It's never not whatever the heck that is. It's not just 2 values subtracted. So we're torn between these two. It's an integral, so it's not a derivative. Okay, so we boiled it down to exactly what, notes 22 or whatever, like the average value section. If we were to divide the b minus a to the other side, then we get the integral from a to b over b minus a equals f of c. And this looks exactly like what we normally for average value. On a scale of 1 to 10, how scared should I be about Riemann sums? 0? Not scared? Wait, I don't know. There is Riemann sums on this, but as I talked about in class, hopefully in every class, but definitely at least in some of them, these are the big things. U sub and properties of integrals. Those are the 2 big ones. I eat my FRQ. You did okay, I would say. When should you change the bounds on definite integrals? Generally, our little human pea brains deal a little better with swapping the bounds in this case, because going from 7 to 1, you have to like think backwards. Whereas if you go from 1 to 7, you don't have to think backwards. That's a really good spot to change the bounds. On the second fundamental theorem of calculus, if your x is down here and you have a number up here, it's often easier to swap these because then it's exactly the second fundamental theorem of calculus. Although with the second fundamental theorem of calculus, you can always do the thing where you say, what's the integral of f? It's big F. And then you plug in the points, so 2 and big F of x, and then you take the derivative and you get that negative just from doing the little fake integral thing. So you have options there. You can also just swap the bounds and save yourself having to think about what the fake integral of some function is by just going from little f to big F. That's the only reason that becomes a negative when we swap those. Okay. Can you do chapter 4, question 4? Yeah. Okay. So, there are a few different ways to think about this. First, we don't integrate absolute values at all. We just can't. We just don't. We just quit. But what we can integrate is if I were to draw this absolute value graph, it's right 3 like Mia. And so from 1 to 3, we're this shape, and from 3 to 6, we're this shape. And so this part of the graph has the equation x minus 3. And this part of the graph has the equation negative x plus 3. And you can integrate these two parts. You can integrate from 1 to 3 of negative x plus 3 and add it to the integral from 3 to 6 of negative x, or sorry, x minus 3. This one. So boink, there, and you can do that, but that's like the more convoluted long way. The shorter way is to realize that these homies are triangles, and you just figure out the sides 2 and 2. That has an area of 2. And 3 and 3. This has an area of 4.5. Half of 3 times 3. And now you just add those two together. 4.5 plus 2 is 6.5, or 13 over 2 here. Bill Anderson. Hello. I'm doing all right. Only big F I'll see is on my test paper for real. That's not one of the options. We go A through E on this test, so you can't choose F. Don't do that. That would be wrong. All right, I'm going to go for question 6. Convert and solve. Okay, a few different ways to do this one. First way. Well, okay, for any of the ways, that's an integral sign. This thing is your dx, and this thing is your f of x. So, probably the easiest way to do this one is to say, yo, I got the integral from 0 to 4 of this case, because width is 4. Width is always the top number over n here. So width is 4. And then our function is just 3 plus x. Because the 4 over n thing times I is x, or width times I tells you how many times you've incremented over. And so that tells you what your x value is. And so this thing is just x, this paradigm. Now you could also integrate from 3 to 7. Could you, actually? I need to think about this. Maybe you couldn't do this one. Let's see, x values start at 3, increment every time. Now this checks out. Of x dx, that checks out. And the last one that I can do for this case here, oh yeah, I'll solve one of these. What is this? X squared over 2. So 49 over 2, yikes, minus 9 over 2, so this is 20. And the last one you could do for this is you could switch it to the integral from 0 to 1. Probably isn't even the last one. By taking this and making it a 1 and putting a 4 in front of this whole thing. And it could be 4 times the integral of 3 plus 4x x. And this would also yield you the answer. But I think clearly these two are easier. But hopefully some of you are savvy enough to pick up on context clues and realize that me going over all of the possible ones might be a relevant thing to know for the test. Maybe. So, grizzly bears are really scary. I agree. One is so goofy. Wonder which one was so goofy. Probably the top one. Do you ever go over the first question in question 4? I did not. I took up like all of its space, but I didn't do it. So the first one in question 4 is the easiest one on question 4, because this is the second fundamental theorem of calculus, so you just plug in x where u is, and call it a day. Blink. That's it. So I over n is just dx. No, width over n is dx. If I go back to that question, 4 over n is dx in that question. For this one and this one, 4 over n is dx. The way we generally write these is, whoops, I can't do that. Limit n approaches infinity of, red, that's really bad. Whatever. I equals 1 to n of, and then we have like f of x in here, but it's really like f of I, because it's like this I thing, but this inside ends up being x. And then this part at the end, the dx, is width over n. Like this. And then the last piece is, when you find x, x is generally I times width over n. But you can also soak more stuff into x by like putting this 3 into the bounds. So you can do it that way too. But generally, you're looking for I times width over n, and that's what x is. Yeah. Oh, that is correct. Chapter 4, probably 3. Yeah, going over the chapter 4 stuff makes sense. Alright, if dy dx equals x, the average rate of change of y with respect to x on the closed interval 1 to 4 is. Alright, so clearly we want to find y, because we need to find its average rate of change. So I integrate this thing, and I get y equals x squared over 2 plus c. Cool. For average rate of change, what we do is we do y2 minus y1 over x2 minus x1 using the y function and x. So I already know the bottom is going to be 4 minus 1. And I know the top is going to be f of 4 minus f of 1. So if I plug 4 in, I get 8 plus c. And if I plug 1 in, I get 1/2 plus c. And you may notice the plus c's canceled. I just left them in here so you wouldn't think I was doing demon magic by deleting it, eating it out of this part. And we just get 7.5 over 3, which is 2.5. So this is a weird question because you're given the slope, but you want to find average rate of change. And so you actually have to integrate it to find the original function, and then use that original function to do the crappy difference quotient and figure out the average rate of change. Not as good as integrating, but you know, whatever. Or, sorry, taking the derivative. So, whatever. Oh, you're talking about the second fundamental theorem one. In this one, you don't actually have to integrate, and the reason why, you're taking the derivative of the integral. So if you were to integrate this, you'd actually get negative sine of 2 pi u over 2 pi. We'd have to do like u sub, or the trick where you can divide by the constant if that is just by a constant. Then you'd plug in 0 and x, and then you take the derivative, which would chain out the 2 pi and kill this 2 pi and change this back into cosine. Oh yeah, also it'd be a positive sign. Because the derivative of sine is cosine. Oh yeah, hint, when you're doing integral questions, always take the derivative of your answer and see if you get your integral inside back, your integrand back. Notice I did that here, and I realized that Will was tricking me. There, with the negative sign. So yeah, you can do this the long way, this one, but if I give some sort of jank, which, you know, I'm likely to do on a test, give you like ln x e to the x times x squared plus 4, something that's really awful to integrate. Like this. Yeah, and then I did d over of this. All you would have to do is plug in t squared and multiply by 2. Wouldn't need to know how to integrate this. Did I just say frick? I don't think so. Did I? Not a big user of that. Wait, did I say the bad word? Whoops. I don't think so. Much more likely I used the real one than. But I don't think I did. I don't think I swore. All right. Anything else people want me to look at? I mean, I got the 16 days of winter break. I got the U sub. I know there's a lot of U subs. See, I got this already. I'm not sure how I'm gonna do these. I'm gonna have to like side screen these with Word because I can only write in Word. Oh, true. I did say it by reading his comment. Dang it, Oliver. Wait, I haven't. Oh, I haven't done problem 5. Okay. Graph looks like this. Because if you factor out an x, U sub please. Literally any of them. I'm not talking about Gaussian integrals. I don't remember any of that crap. I have to look it up. Ask the versus Brown or whatever that. So anyways, since the integral looks like this, all we're finding the area is of this stuff. So it's just going to be the area of that stuff divided by 3 from 0 to 3. So you would just have to integrate dx minus x squared from 0 to 3. And you get 3x squared over 2 minus x cubed over 3, and you chuck in the 3, and put it over this. What do you get if you do that? 13.5 minus 9, so 4.5 over 3, 1.5. Chillin'. That one. Go over quiz questions for USEB. I haven't looked at the USEB quizzes yet. I can try that. Get a blank Word page. The quizzes were all different in the different classes, so I can certainly try to figure out one looks representative of the difficulty. Then I'll go back and do something from chapter 2. Okay, so the question I pulled up from the quiz was from period 6, and it looked like cosine of x plus 5 cubed times sine of x dx integral. And all you have to do is make u equal to the inside. Cosine of x plus 5. The derivative of cosine of x is negative sine of x. And we have a positive sine of x. So multiply both sides by a -1, and you get negative du equals sine x dx. We can substitute negative du in for this stuff, and we get integral of u cubed times a negative du. And this just integrates to the u to the 4th over 4 plus c, and then you chuck in what u equals again. Get negative cosine of x plus 5 cubed, 4th rather, over 4 plus. The other one from this was really similar. It was x squared over 16 minus x cubed squared x. And what you wanted to do here was make u equal to the bottom. I just write. 16 minus x cubed, not the squared thing, because we can see that we have the derivative of x cubed here on the top with x squared, but we do not have the derivative of x cubed squared. Gonna keep the inside as our u, and the du would be negative 3x squared dx. I only have x squared dx, so I'd have to divide by negative 3, and that would. And we get 1 over negative 3 times integral of u squared on the bottom, which is u to the -2, and du. I also realized I kind of skipped over this du. 1 over -3 comes from this calculation. Whatever you have to do to du, just put on the outside of the integral and save yourself it looking janky. And then you just integrate, so -1/3 times u to the -1 over -1 plus c. And the negatives cancel, so you get 1/3 times 1 over minus x plus c, because -1. So the answer would probably look something like 1 over 48 minus 3x cubed on a test. Okay, is there a thought process in what you want u to equal? Definitely. So the thought process is whatever's most on the inside generally is a good thing to make u equal to. So because u is because 60 minus x cubed is on the bottom, it's a likely u candidate, and because it's inside a squared, it's an almost definite u. The top is not a good u candidate because the derivative of x cubed is x squared and not vice versa. I mean, it's like 3x squared, but it's like close enough that looking for a power that's one smaller is often how you find du. So there is 100% a thought process. Look for the thing that's most inside, make that u, take the derivative of that, see if you can get it to match, or alternatively, solve for dx. What I call the Krusich method. You don't want to like figure out what you need to multiply by. You do this and then plug it in for dx, and then this sine x on the bottom will cancel with the sine x on top. Ultimately, it's exactly the same thing, just a little bit different of a method. All right, hopefully that was illustrative of some U-sub. I realize I was really messy with how I wrote this. Oh, whoops. Gosh darn it. I am very inaccurate with my writing right now. Okay, I want to go to question 2, 3. Okay, so at x equals pi over 4, the rate at which sine squared x is increasing is k times the rate at which x is increasing. Oh yeah, I always hate these questions. Just take the derivative of sine squared x. That's the rate it's increasing. And it's k times the rate x is increasing. 1, because x is 1. That's its rate. Then you just solve for k. Plug in pi over 4. You get 2 times sine of pi over 4 is root 2 over 2. Cosine of pi over 4, 2 over 2. 1. 2 times a half. 2 times 2 over 4, or however you want to think about this. That knocks that out. X. What is chapter 4, question 2 asking for the slope of that one? What's it asking for? It's asking for what this thing equals, which is this one. And I went through why. Like, all the rest of these are like derivatives or that sort of thing. You need the one that's actually like representative of an integral of the thing, which is applying like a height by a base. Additionally, it's also exactly, no, it's 22. Exactly. But yeah, there's a missing. How different were the other quiz? They different? Not really. They were all the same style where you just had to like divide by a constant or whatever on the outside to get the match. Yeah, the equal sign wasn't on the paper. That's someday I'll fix that, he says. No. So I did get general U-sub questions, so I can pull up this thing, or I could even like go on the internet for random U-sub question, or I could just make up my own. While I'm waiting for a question, that seems like fun. Make up a fun U-sub question. What's fun that we actually know how to do? Do something like fun, and we know how to do it. So this doesn't look like a U substitution question, but this absolutely is a U sub question. So the reason why this is a U sub question is because you can factor this bottom. What I'm teaching in Algebra 2 right now is like, when in doubt, factor the bottom. And we have like an x squared plus 6x plus 9 sort of thing. So this is like x plus 3 squared. But because this is x to the 4th and this is x squared, it's going to be x squared plus squared. And what's snazzy about this is now the derivative of the inside does look like my top. And so now we can say u equals x squared plus 3. And we can say du over dx 2x. And we can multiply the dx to the other side. And I have an x dx instead of a 2x dx, so I can divide by 2 on both sides. We get du over 2 equals x dx. So now I can rewrite the integral as just 1/2 of integral of this thing here is u, so u to the negative 2, u. And now we just get 1/2 u to the negative 1 over negative 1, and this ends up being really similar to the last u sub I did. Nice pie charm icon, lol. Yeah. There be anything like... Oh, yeah, sorry, I should not get distracted by chat and actually finish the question. There we go. That looks fresh. You? Okay, that was actually cool. Yeah, I think so. What other... Okay, so there's the other really important thing that I'll talk about. U sub with trig. Okay, I can do this with trig. So... Oh yeah, you guys are gonna see a gnarly thing on my face. I say it's my wife's fault, but really I just slipped on the deck in the backyard and face planted. So now I have this massive gash on my forehead and very bruised nose. Kind of funny. Hurts. So anyways, the thing I wanted to talk about, how do I make this U sub right? I go from pi over 4 to pi over 2. That makes it sub of with trig. What do I want to do? Really so much I can do. Here, we'll do tangent of... No. Yeah, this is fine. Tangent of x times secant of x tangent of x dx. Is that right? No, I messed up. That's a really hard one. Make this a secant of x. There we go. And I kind of served this one up here as a trig question by separating it like this. It happens to be that the derivative of secant is secant tangent. So how do we find our combo here? We could just call this u and the second thing du. Or we could make u equal to tangent of x and make du equal to secant squared of x. This one has two different ways to go about setting it up. So I'm going to get rid of all this junk here and show you these two integrals we can make out of this thing. So our first integral, if we make secant equal to u, we would get secant... oh, no, sorry. We would get u, since u equals secant of x, du equals secant x tangent x dx, derivative of secant. And so we could just rewrite this integral as the integral of u du. But there's something a little special here, which is we have bounds on this one. And so the reason I add bounds is we can now convert our bounds, provided we can figure out what the secant of pi over 4 is and what the secant of pi 2 is. Did I run into a problem? Should I have picked pi over 3? Yeah, pi over 3. More careful when I pick these. All right, so anyways, if it's pi over 3 and pi over 2, then if I plug in the top bound, secant of pi over 3 is 1 over cosine of pi over 3. Cosine of pi over 3 is cosine of 60 degrees or whatever, so that's a half. Here on the unit circle. So it's over a half up root 3 over 2. So that's 2. 1 over a half. So top bound would be 2. And bottom bound would be at 45 degrees. And so that one is root 2 over 2. And if it's 1 over, it would be 2 over root 2. So cosine is root 2 over 2 at this point. But secant is 2 over root. And again, I'm using this u to convert my bounds. So the benefit of this is now I can just do u squared over 2 plus c. Oh, I don't even need plus c. I'm plugging in bounds. And then we can just plug a 2 in. And we get 4 over 2 minus 2 over root 2 squared is just minus 2 over 2. So you get... Cool. Our other way of doing this would be to make u equal to tangent of x, and the derivative of tangent happens to be secant squared of x dx, which makes this stuff our du, make u equal to x. And now what we do is we'd rewrite this integral. It's still u to u. We have exactly our stuff here. But now our bounds are going to be different because this time they're tangent. So tangent of pi over 3 is tangent sine over cosine. So it's root 3 over 2 divided by a half. That's root 3. And my bottom bound, plugging in pi over 4, tangent of pi over 4 is just 1. Both sine and cosine are root 2 over 2 at 45 degrees, or at pi over 4. And so we'd get this, and now we'd integrate u squared over 2, and then plug in these bounds. And ideally, if we plug in these bounds, we get the same answer. Let's check it out. 3 over 2 minus 1 over 2. Jiggy check. That's 1. Nice. So how about that? I did a trig question where you have to change the bounds, and solved it with two different techniques. One where we made u equal the tangent of x and du was secant squared, and one where u was secant of x and du was secant tangent. X tangent x. Should we expect a lot of trig, Useb? No, I was just asked about it. I don't know. I would bet that there's one at least trig question, because all I can ask you right now is power rule stuff or a trig. So chance that there's trig, reasonably high. I would say higher chance that there's like sine x or cosine of x in your trig, so it looks more like this one kind of use of. Every time you say change the bounds, I die a little bit inside. Changing the bounds makes the question easier. I promise you. Now, this one was like kind of janky because we had to figure out what like tangent of pi over 3 was and tangent of pi over 4 was. But you'd have to do that anyways after you integrated and plugged back in tangent here. You'd still have to plug in pi over 3 and pi over 4 into the tangent function. So by converting the bounds at the beginning, we kind of save ourselves work in our final step. It's like a little bit of work ahead of time so that your work is cleaner and you're less prone to mistake later in the question. Our question is going to be this difficult with the whole bound switching and stuff. Oh, no question I'm going to put bound switching stuff on there. Or stuff where it would behoove you to switch bounds. So there's a type of AP question that's given where this is the question here at the beginning, thing that I've horribly mangled at this point, and these are the answers. And it's like, pick the ones out of the list that are equal to the original question, and it's like, both of these are, but this homie over here, that's the integral from 0 to 2 of where du is not a good one. You know, like that sort of thing. I would say that this one was fairly difficult, but within the realm of things that could be on the test. The question I here with tangents. What kind of integral properties quiz? Like, just look at all the integral properties. that's the stuff. Like, insert page break after all this stuff. That's fine too. So, like, the quiz for that section was pretty representative. Like, where you have something from 1 to 3, and you have another thing from 5 to 3. You're asked to find the integral from 3 to 5 of them together. This sort of thing. This could be on there. Trying to mangle one of these questions here. And this would be like -1 from 1 to 3. Oh, whoops, I was trying to find the interval from 3 to 5. How about more fun? 1 to 5. There we go. And now we just take the integral from 1 to 3 and add it to the integral from 3 to 5, so we'd have to invert the second homie. And -1 plus -2 is -3. That would be, well, like those sorts of questions, that style. The integral from 2 to 2 is 0, whatever. What else is? I like that you're allowed to pull out a constant, so 1/3 f of x dx is the same as 1/3 integral of f of x dx. That's a property. Just definitely need to know all those properties and know like which ones are real. Okay, so the big problem people have with integral properties is people get to a test and they think this is a property. Uh, they're like, oh yeah, I could just go x squared over 2 plus x squared plus 1 cubed over 3, or sorry, times, whoops, plus c. Chillin'. No, this is garbage. This is hot garbage. If you're ever multiplying two things that you have power ruled, integral wise, you have done it horribly wrong. You should never have multiplied things that are both individually power ruled. We do not have a product rule or any sort of rule for multiplied things. It's why we do u sub. It's why in this question we would have to make u equal to x squared plus 1 and then get du equals 2x dx and then get u over 2 equals x dx. And then if we replace the stuff with the u's, all we're left with is something that isn't a product. U squared times du with a 1/2 in front. This is just a single power rule function that we're allowed to integrate. So it's almost as important to know what isn't correct as to know what is correct. We only have like 5 or 6 rules and they're all pretty easy. Like the pulling a constant out is pretty easy. The adding things together, the switching the bounds, like all that stuff in abstract by itself is, but it's when people get baited by things that aren't real tricks, like thinking that the integral of f of x divided by g of x dx is the same thing as the integral of f of x dx divided by the integral of g of x dx. This is not a property. This is hot garbage. Hot garbage. Like the stinky kind. That is not a real property. So that's, I guess, my warning there. Is you need to know what the rules are to identify that it's an integral rules question, and you also need to know what the integral rules aren't to identify when you're not going to use them. Tea time for me. All right. We actually wrapping up questions this early? Am I chilling? Love to hear that. I have to go into school early tomorrow to copy the darn test for first period. God, I hate starting on Tuesday. I have calculus in the morning, and then I have flex, and then I have algebra 2 like directly afterwards. No prep time. Going early. Oh. How would you solve that integral question? Oh, this one? The only way we have to solve this right now is simplification. Maybe if you know what the functions are, you can simplify it. Or u sub. Maybe f of x is the derivative of some g of x or some part of g of x. We otherwise have no way of solving it. Like, for instance, the integral of x over cosine of x. This is just straight up sad face. We don't get anywhere near this. No way. Oh, hiccup. Love flex. You're stuck with me. Limits, how about 12/28 they? Okay, I can go there. Chapter 2, question 2. Chapter 2, question 2. The volume of a cube is increasing at a rate of 20 cubic centimeters per second. So, side cube, derivative, size squared, SD 20. The rate of change of the volume. How fast in square meters per second is the surface area of the cube changing? So 6s squared, surface area of a cube, because there are 6 sides. Cube. And then you take the derivative of that, and you get 12s ds. And then it says when each side of the cube is 10 centimeters long. So I can plug 10 in for all the s's. So if I plug 10 in for the s up here, I get 300 ds dt 20. So ds dt is 1/15. 20 divided by 300. And then you just chuck that homie in down here along with the 10. 12 times 10 times 1/15. And 120 divided by 15 is rocking it. So it's just a matter of knowing the s cubed formula and the 6x squared, taking the derivative. Remember to do it implicitly because it's with respect to time, and s is not t. And question. It's actually very similar to a retake question. I've done. 12/28 limit. Okay. Cal. Okay, so I need to enable editing. Okay. And so this question, if you plug in 1, you get 5 and 2. Those don't match, so undefined. If I ask for the limit from the left, it'd be 5. Right, positive. It would be 2. Here. Chapter 1, problem 2. Sure. That's limits, probably, maybe? No, it isn't. Which of the following functions are continuous? So, if you plug 1 in to natural log of x, yeah, natural log of 1. That's chillin'. Can't put negatives or 0 in natural log, but plug 1 in, totally fine. Plug 1 into an exponential, e to the 1. It's e, chillin'. Plug 1 into this bottom thing. You get e to the 1 minus 1. That's like 1.718. And natural log of that, chillin'. So, which of the following are continuous? All of them. Yep, that's kind of it. Big chill that one. That's 12/18. Oops. Okay, 12/28 it is. That's why having a chat is helpful. All right. Limit as x approaches infinity. Big powers. 1/4. Ratio of the leading terms. Limit as x approaches 0. Smaller powers. Ratio. Negative 1/2. Limit as x approaches 0 of 1 minus 1 over 0. 0 over 0. This sucks. So we could either use trig rules, like you could say sine squared theta equals 1 minus cosine squared theta. And then you could factor 1 minus cosine squared theta into 1 minus cosine theta times 1 plus cosine theta. That could work. You could cancel the top. 1 plus cosine. Yeah, so that's the hard way. That's the way without calculus. With calculus, we do L'Hopital's on this, which is when we have 0 over 0, we can take the derivative of the top, sine theta, and take the derivative of the bottom. Take out a 2, 4 times sine of theta times the derivative of the inside function. Remember, sine squared is the same thing as sine theta. squared. So I pulled the 2 down, multiplied it with the 2 in front, rewrote the sign, and then multiplied by cosine of theta. Now you can cancel the signs and plug in 0 and get 1. And the first question on the review is actually very similar to the question. My stream is so lagged behind. Wild. Like a minute behind. Can't give me feedback in real time. Bad. Okay. Play some games right now. Work? Yeah, there we go. Oh, it's slower. Substream. 4, 5, 6. See if any other questions come in. Otherwise, I'm pacing. Good. Enough. uh. Number 4, question 2. All right. Get out of there. Chapter 2. Chapter 2. 5 stack vol with us. I'm so confused. So implicit. Right question number 4, chapter 2. Yes, I can do. It's not a lovely Tkinter GUI. Tkinter's hideous. I'm trying to learn key right now. I can make better looking GUIs. That's why I had stuff open. So if you take the derivative, you take the derivative of x cubed, that's 3x squared. You take the derivative of 3xy with the product rule. So 3 times, the derivative of 3x is 3 times y. And then 3x times the derivative of y, which is y dx. And then when you take the derivative of 2y cubed, you take the 3 down, you get 6y squared dy dx. That equals 0. And now you just move the terms that don't have dy dx to the other side. Negative 3x squared minus 3y equals dy over dx times dx plus 6y squared. And then we divide by dx plus 6y squared. And we get the answer. Or we don't really get the answer, because you can divide by 3 on top and bottom and get this to match one of them. You can also take the negative out on the top and put it in front. And that's probably what the answer looks like. This. And sure enough, it does. That allows us to match the answer. I let go of 2-2. Perhaps. Did you already go over 7? I have no idea. 7 this one? I don't know. I'm tired. Epic minigames? Epic minigames. Got the Robloxers chat here. Enough. Have a good night, y'all. Those of you at first period, good luck tomorrow. Good luck to me tomorrow, having your test ready and eating dinner. Yes, do that one, please. What? Do what? What? Not doing Roblox. No, I'm not playing epic mini games. No. All right. Have a good night, guys. Peace.